All right. So again, the first few problems we're going to be doing involve the Pythagorean theorem. A squared plus b squared equals c squared. I don't like this problem. This is one where we're just measuring the diagonal of a credit card. And again, you're given centimeters for your height of the card and your width of the card, and you're using the Pythagorean theorem to solve for that diagonal. Sometimes you're given pictures, sometimes you're not. So sometimes you have to draw your own picture. So here's one where it says a boat left the dock and traveled 30 miles west, then turned and traveled 40 miles north. How far away is the boat from the dock? If you guys aren't sure of the directions, like north, south, east, west, if you need to look it up, feel free to look it up. You guys ever heard the never eat soggy waffles? All right, so whatever helps you remember it, but just make sure that you are, if you're not given a picture, that you're able to draw the picture. So if our measurements are 30 and 40, and they want to know how far you are from where you started, right? You can use the Pythagorean theorem. You got A, B, and C. Plugging the values we have in or the variables we have in would give us 30 squared plus 40 squared equals x squared. 900 plus 1600 equals x squared. 2500 equals x squared. To get our solution, we have to take the square root of both sides. And what we end up getting here is an x value of 50. Now, it doesn't always work out that clean. I will say that in most problems, it'll tell you what you need to round it to. It's usually to one decimal place. So some of these will be things that you need to round to a decimal place. So x ended up equaling 50 there. Okay. All right. Ladder problems. I do want to go over a couple ladder problems because the ladder problems are the hardest ones. And I will say that this ladder problem isn't the hard one, but the next one is. It says a ladder is 20 feet long. Its top is leaning against a wall with its base 8 feet from the wall. How high up the wall is the top of the ladder? So again, if you were given this description, this is what the diagram would look like. You got a 20-foot ladder leaning against the wall. The base is 8 feet from the wall. So the base of the ladder, the bottom of the ladder is 8 feet from the wall. And we want to solve for the height the ladder is up the wall, so x. All right, so let's identify, we got our right angle. Make that A, that B, and this C. So x squared plus 8 squared equals c squared. Nope, not c squared, 20 squared.
Last interruption, folks. We're finished. You all did a good job. All the doors were locked. That's what we needed to have happen. Good job. Have a great day.
So x squared plus 64 squared, or x squared plus 64 equals 400. We subtract 64 from both sides. It's 336. So I need to take my calculator, take the square root of 336. And I get 18.3303. Round to one decimal place, 18.3. So x is about 18.3 feet. Okay. And that makes sense because it can't be longer than 20. And 8's not a crazy long length, so it's probably gonna be fairly long, close to 20. All right. That is that example. So I want to go over one that's a little bit more difficult. Not this one. This one's just a football field where you're trying to find the distance from one corner to the other. Same idea. You're gonna have a right triangle with a diagonal. Here's another one where you're walking two distances, 7 miles south and 2 miles east. All right. When I originally made this, it was like December. It was holiday season, so I made the problem where I was hanging lights. Mr. Newberry was hanging holiday lights this past weekend. The ladder he used is 18 feet long, and the bottom of the ladder is 4 feet from the house. So I'm going to go ahead and draw that situation first. So we've got the house, and the ladder is 18 feet long. Let's do this. I know it's not drawn to scale. 18 feet long, and the ladder is 4 feet from the house. Okay. As he's putting up lights, when the ladder slides down the wall, it stops. So I'm on the ladder and it slides down. So pretty scary stuff. So now it's slid down the wall. The ladder is still 18 feet long. All right. So when Mr. Newberry gets to the ground, he notices the bottom of the ladder slid 2 more feet away from the wall. So it was originally 4 feet away. Now it's 6 feet away. How far did the top of the ladder slide down the wall? So what we have to do in this case is compare. We use X, let's say Y. We have to compare X and Y. We have to figure out how far down the wall it slid. All right, so there's a distance that the top of the ladder went down. We have to figure out what that distance is. All right, so we have to use the Pythagorean theorem twice. Now, sometimes you may be given a question like this where maybe you have to figure out how high the ladder is up off the wall, and then you're told that it slides 2 feet down the wall. So then you've got to determine this height, subtract 2 from it, plug it into this one to figure out how far away from the wall it slid, right? But in these ladder problems, you've got to figure out, you're going to have to use the Pythagorean theorem twice. And sometimes you have to use the solution from one of the triangles in the next triangle, okay? So in this case, we'll use it twice, and we're going to have, we'll go A, B, C. So we got x squared plus 4 squared equals 18 squared. And on the right triangle, we'll do same A, B, and C. So y squared plus 6 squared equals 18 squared. All right. And do 18 squared minus 4 squared. I'm just subtracting this from this side and that side. So 18 squared minus 4 squared gives me 308. So x squared is going to equal 308. Taking the square root of 308. I get 17.5499. So around a 1 decimal place, it'd be 17.5. Look over here. I'm going to do 18 squared minus 6 squared. I get 288. When I take the square root of 288, I get 16.97. That's going to round up to 17. Okay. So it was 17.5 in the first situation, and it was 17 in the second situation. So the ladder slid down 0.5 feet. It slid down half a foot. Okay. again, I had to compare those two triangles to get to our solution there. All right. That was our last example using Pythagorean theorem. I'm going to go over some of the ones using trig next. Before we do that, though, we have to talk a little bit about some terminology here. When we're using angles, because trig is all about angles, so we have to be able to determine which angle we're talking about in an application, okay? So when I say angle of elevation, okay, angle of elevation, think about somebody standing on the ground and their eyesight is level, okay, with the ground, okay? The angle of elevation is the angle that you look up at something. Okay, so if I'm looking up to the top of a building, it'd be the angle that your eyesight, level eyesight makes with the angle that goes up towards the building. All right, that'd be an angle of elevation. An angle of depression is the opposite. It's taking your level eyesight and it's when you're looking down at something. Okay, so things that are up in the air, when you're looking down at something on the ground, that's going to be an angle of depression because you're looking from horizontal, you're looking down. All right. Now that's important because that's going to identify where the angle is located in your triangle. The angle of depression can confuse people, and that's the one that people usually get mixed up about where that angle is located in their triangles. So we'll go through a few examples today to try and help you out, and hopefully you guys understand where those angles can be represented. I will share these slides with you guys too, so you guys can see them, in case you need to go back and look at them. Suppose you're flying a kite and it gets caught at the top of the tree. You've let out all 100 feet of string for the kite, and the angle that the string makes with the ground is 75 degrees. Instead of worrying about how to get your kite back, you wonder, how tall is that tree? It's a really tall tree. All right. Let's go ahead and let's draw this situation. So, you got the ground. You got you with the kite. And you got a tree. I know it's not a very pretty tree. Sorry, I actually like it when they look a little nicer. All right, and your kite is stuck at the top. And your string is all the way. Okay. Now it says you got all 100 feet of your string for the kite is let out. So that 100 feet is that hypotenuse there. Now, somehow you're really good at measuring angles on the fly and you figure out that it's 75 degrees. It's a 75-degree angle up to the top of the tree. What we want to find out is how tall the tree is. Okay. Now, you can't use Pythagorean theorem here because we're not given two sides. Okay. We're given an angle measure in one side, so we have to use trig. So this is where we're going to use.
If you would use trig to find.
So we got our angle, so label your sides. Opposite, hypotenuse, adjacent. And in this case, we're going to use the opposite and the hypotenuse. So that is sine. Sine of our angle, which is 75, equals opposite over hypotenuse. X is high, multiply. So X is going to equal 100 times sine of 75. So that tree's height, make sure you're in degree mode, whatever calculator you're using. So 100 times sine of 75, 96.59, so round up, 96.6. the reason I know my answer is in feet is because the length unit we used here, 100, was feet. So that will also be feet. So the tree is almost 100 feet tall. It's a really tall tree. Good. So again, it's a matter of setting it up correctly, and then from there, it's using the trig functions, just like we have in the last few days. All right. A fire department's longest ladder is 110 feet long, and the safety regulation states that they can use it for rescues up to 100 feet off the ground. What is the maximum safe angle of elevation for the rescue ladder? Okay, so in this one, we've got the ground. So we have a building here, and we've got the ladder. In this one, it says the ladder is 110 feet long. They said it can rescue up to 100 feet off the ground. So let's say it's at its maximum, the highest it can possibly go, right? Which is rescuing something 100 feet off the ground. They want to know what's the angle, the maximum angle of elevation that can be at in order to get to 100 feet. Right? So same idea here. We got our angles right here. So we got opposite, hypotenuse, adjacent. Looks like we're using sine again. But this time our angle is our variable, sine of x, equals 100 over 110, opposite over hypotenuse. In order to solve for the angle, that's when we use the inverse. So x equals the inverse sine of 100 over 110. So inverse sine 100 divided by 110. 65.38 or 65.4. Now, this is a degree measure, so 65.4 degrees. And you can put the degree symbol or write it out, degrees. If they're looking for a degree, they may actually, on the test, they may actually just give you a blank, and then afterwards would be the word degrees. All right. Now the one that, I think that might actually be all of the example problems. I thought I had one angle of depression problem, but I don't see it here. Let me see if I can pull up the one that I was thinking of. I think it's this last one on here. Nope, that's an angle of elevation problem. I thought it was an angle of depression. All right. Tell you what, I'm going to share the assignment with you guys, and we'll pull up one of the angle of depression problems and work on it together.